have seen again that this work, the early days of the mobile agent research community, where it was confined to research, is now changing. We're moving into the commercial arena. People will not be selling something that other people are not willing to use or buy. Okay? So basically we have all of that. We also see the emerging paradigm of integrating the BDI architecture with agent mobility so that we have agents which are autonomous, which have the ability to reason, but are more powerful than that because they have the ability to migrate. Are you going to tell me that an agent which can be autonomous and reason but cannot migrate is potentially more useful or more beneficial than an agent which can migrate? I don't think you can tell me that. Touch your hearts honestly. I think every which way you look at it, agent mobility is a useful and important feature. We can do more with agent mobility than we can do without it. Thank you.
Thanks very much. Now, not enviable task of the negative team, try to refute the usefulness of those agents. So, Mohammed, you.
Yep.
Okay.
Good morning, everybody. We will start our presentation here by a main thing about what is the difference between mobile agent and mobile code. Because all the advantages they said about mobile agent, actually it is for mobile code. Mobile code is a piece of software that could be migrated from one host to another under the control of the host itself. But mobile agent is the piece of software that can migrate from one host to another autonomously from itself. So this is the difference. All these advantages for mobile agent is for mobile code, not mobile agent. We will see now these advantages that is claimed in the literature. They reduce network load, they overcome network latency, they calculate protocols, they execute asynchronously. All this for mobile code, not a mobile agent. Actually, there is a contradiction in the mobile agent itself, in the definition of mobile agent. Agency and mobility has a contradiction in itself. The notion of being an agent contradicts the notion of being mobile, because the more autonomous, the more size, the less mobility. As we see, the more robustness, more size, less mobility. The more reliable, the more size, the less mobility. So there is a contradiction in the definition of mobile agent itself. For real-time application, as they claim in the literature as well, the time overhead for the agent to go to the host, to pack itself and unpack itself, and to be compiled, makes the mobile agent is not a solution at all for any real-time applications. And the decision code is another overhead. The agent has to carry the code to decide where and when and why to migrate. And this is an overhead over the network. Here there's an interesting point about the mobile agent technology. The mobile agent technology has been started a long time ago, more than 10 years now. Where are the real systems that use this mature technology? 10 years. 10 years, there is no real system till now. Why we don't see mobile agents roaming Monash networks? We don't see in our systems mobile agents go there and here and...
Maybe they are, we just don't know.
Actually, during this time, during these 10 years, we were struggling to solve the problems raised by mobile agent technology, rather than using mobile agent technology in implementing real applications. We lasted more than a decade to solve a part of mobile agent problems. So imagine how complicated, how will be the performance for this technology. More than 10 years to solve a problem. Here's a simple formulation about the cost of RPC, remote procedure call, and the cost of mobile code and the cost of mobile agent. We have here, for mobile agent to do its task, has time for mobile agent execution, which is more than the time for RPC, of course. Time of packing and unpacking in each host. The mobile agent has to pack itself and unpack itself. And the time of transferring the mobile agent code size across the network. The mobile agent autonomous code size, this is especially for mobile agent, not for mobile code and not for RPC. And the accumulated results, it carries the results and it goes roaming the network carrying the results. So it is obvious from that mobile agent cost is much bigger than mobile code or RPC. So why to use mobile agents? There is no applications, no killer applications.
1 minute.
Finish.
Finish.
Yeah.
Thank you. Thanks.
Okay. So as we've seen, we can already use the current technologies of mobile code, such as applets or servlets or even HTML emails that we are currently using as mobile code to have the benefits that are claimed to be the benefits of mobility of mobile agents. So we just gain more complexities and overheads with mobile agents when you introduce the autonomy behavior and other aspects of mobile agents. I will now show you an e-commerce scenario, perhaps the most cited scenario in favor of mobile agents. One is suppose mobile agents are supposed to excel in. And let's see what happens when you introduce the mobile agent paradigm. So we have this mobile agent is launched on behalf of a user, and he has this big plan. He's going to roam the network and he's going to visit remote hosts. And during this time, he's going to retrieve information, make computations, and reach a decision for his user, and eventually buy an air flight ticket and make an hotel reservation. So initially, what happens as he travels along the way, it consumes more and more resources, it retrieves information needed for his computations, and it gets bigger and bigger in size. The first problem it encounters is when it travels to one of the host servers. There he finds it's flooded with mobile agents from all different origins and sizes and types. What happens here is that the hosting server has a problem. The problem is it has to control the resource consumption of those mobile agents. These are external entities, not controlled by the server, and they are autonomous. A hosting server does not know what is the behavior of those mobile agents, since they're autonomous, and does not know how they're going to consume any resources that it gives them. So this server has to deal with other complexities as well that are introduced by the mobile agent paradigm, such as managing the mobile agent security or executing their code. And as I said, limit the resource consumption. So when there are too many mobile agents going around and taking too many resources, the only thing such a server can do is just kill processes that consume resources. In other words, kill some of the mobile agents. Now, when a mobile agent is killed, it is almost unrecoverable. That's because all the data that he has taken along the way is lost. And the originating program that has launched this mobile agent might not know his whereabouts. He's totally autonomous somewhere in space. Yeah, so it's a very big issue of recovering mobile agents. Let's suppose our agent survives and continues. He then comes to another server. Here he tries to he acquires some resource, R1, while another agent in a nearby server of another company, Agent Cruz, comes and acquires another resource, a similar resource that is needed for his computations. Both agents then travel to each other's location and are waiting to each other agent to release this resource, which of course doesn't happen, since what we have here is what is called distributed deadlock. They can wait forever. And the problem with distributed deadlock is much more severe than regular deadlocks, because it is almost impossible to detect such deadlocks, because, for example, here, Hotel A has no knowledge of what is happening at Hotel B. It's another server, it's another company, it's another domain. It does not know it. It's very difficult to trace this deadlock. On top of that, mobile agents are autonomous, right? They might come back and release this resource. So it might not be a deadlock after all, but it is in our case. So they can wait forever. Let's suppose that our agent has some mechanism and then after some time continues his traveling. Then he leaves this Hotel B without retrieving the information and continues. Next, he comes to another place. He's been executed by another server. This agent is in the mercy of this hosting server. It executes its code. It's just static code being executed by the server. This hotel happens to know that the next hotel, close by hotel, has a better deal to offer this agent. Therefore, he tampers with a mobile agent code, and instead of having one reservation, it requests now 1,000 reservations. This agent then comes to the other host, requests 1,000 rooms, which of course are unavailable, and his request has been rejected. Eventually it will come back to the first hotel and get the wrong deal on behalf of its user. It's a matter of trust, and a matter of security as well. And finally, as you can imagine, our mobile agent doesn't make it on his way back home. He's stuck in some low bandwidth network carrier and perhaps a mobile computing environment, perhaps on the way back to his mobile user. And of course, he doesn't make it. So let's sum up and see what we have here. And just remember, this is just one example of a very favorable scenario for mobile agents. E-commerce. We have uncontrolled mobile agents flooding the network and the servers. We consume too many resources and are unmanageable. Recovery of mobile agents is a very tough task. When a mobile agent is killed, we don't have his data anymore, and it's hard to trace. Distributed deadlocks and live locks, hard to detect by the hosting server, even impossible. Tampering with the agent's code is just one security problem out of many security problems. We'll hear about more of that later. Some of them are said by security experts that are unsolvable.